Hey, everybody, and welcome back to the Rule Your Pool podcast. Exciting times. I have someone else to talk to. You're not just stuck with me talking alone like you have been for so many episodes. Returning to the show after, almost a year maybe, Joe Sweazy. Welcome back.
Hey, thanks, Eric. I don't know. People like hearing you talk to yourself because you get down that rabbit hole sometimes. It's pretty entertaining. I'm here to pull you back out a little bit.
Yeah, the problem is we just keep losing viewers, right? We're trying to get past that 300. And you make some songs, you make some jokes, and next thing you know, we're back to the 17th most popular pool podcast. And we're just trying to break into that top 15, you know?
Yeah, there you go. No songs in this end, no. I don't want to hurt anybody's ears.
Well, I don't know about that. But anyway, this was your idea. You wanted to talk about this subject because we do get a lot of questions about it. And you have over 20 years experience in pool testing. What are we talking about today?
I just wanted to talk a little bit about cyanuric acid testing. It's a question that we get occasionally because obviously being in the sanitizing and disinfecting business, cyanuric acid is an important part of it, right? Mm-hmm. And so testing that and being able to get an accurate result, it's part of the LSI, and we've talked about that a lot. It's one of our 4 pillars. Mm-hmm. So I thought that we should focus a little bit on that testing part and make sure that everybody understands that there are limitations of the tests that are out there. So that's what I thought we should talk about here.
Great idea. You may get an occasional question about it, but you're not getting all the influent podcast emails and help center requests. And we actually get asked it at least once a week. And it's not usually just about CYA. The main question I get is, well, how do you test for the things that the main test kit doesn't pick up? Like, how often should I test for CYA? How often should I test for temperature? How often should I test for these other things? And as I say to most people, you should test every week for temperature, pH, chlorine, and alkalinity. And then probably once a month or so, calcium, CYA, and TDS. So with that being said, let's go. Welcome to Rule Your Pool, the podcast by Orenda that explains and simplifies pool chemistry so that anybody, regardless of experience, can understand it. I'm your host, Eric Knight, bringing clarity to these subjects so that you can bring clarity to your water. If you're ready to rule your pool, then let's go. Okay, Joe, the floor is yours.
Yeah, so let me back up to something that you said in the intro because I thought it was interesting, and you talked about how frequently you should test those parameters. Cyanuric acid being kind of that one you look at monthly. That's great. That's a very good way to look at it if you're not using tabs. Typically, you're adding cyanuric acid to prevent the loss of chlorine due to UV degradation, right? It's your sunscreen, your sunblock for the chlorine. And if you're using tabs...
Hold on. For the audience, what are tabs?
Tabs are trichlor. You put them in a tab feeder or some sort of a slow erosion device floater that allows those things to be fed. And those contain cyanuric acid. Right. They're automatically loaded with it, right?
Yeah, so just for the audience, trichlor is a stabilized chlorine. We discussed many episodes ago that by weight, 55% of it is actually cyanuric acid and 46.8% or something. I don't remember. But less than half of it is chlorine by weight. Now, it does have a high available chlorine percentage, but most of it is CYA. And the most common use is a 3-inch tablet, kind of looks like a white hockey puck, but it can also come in a granular shock. So Joe, back to your point, if that is your primary chlorine and you are regularly adding trichlor to the pool, the CYA is going to climb.
It is, and you should be testing more frequently, particularly in periods when you're putting more trichlor in the pool. Mm-hmm. So if you're adding more to the pool than you normally do, probably should be testing that on a weekly basis to make sure that you're keeping track of what that looks like. Mm-hmm. Or if you know based on what you're adding, I mean, it's math, right? It's science. We've talked about that. If you know how much trichlor you're putting in the pool, you should be able to calculate about how much cyanuric acid you're adding. So taking that into consideration.
Joe, you don't even need to do that because you can now use the new Orenda Chemiculator, second option on the Orenda calculator. If you go to the main menu, you can go in there. It is behind a login, but you can fill out your pool volume. And based on that pool volume, you can select a specific chemical and on a dial, select the exact amount that you want to add. And it will tell you not only how much chlorine it adds in the case of trichlor or dichlor, it'll also tell you how much cyanuric acid it leaves behind as well. So you don't really have to calculate it. We've built a calculator for you and it's totally free.
Awesome. one way or another, figure out how much cyanuric acid you're putting in the water. If you know what the baseline is based on your monthly test and you know how much you're putting in, great. If you don't, test it.
And this goes for dichlor too. It's not just trichlor.
Right. Also a stabilized, less used, but also very important. Mm-hmm. So getting into the testing, right? Most everybody uses a pretty common test called melamine. And it's typically referred to as a turbidimetric or vanishing dot or vanishing eye, whatever it's called. It's using a melamine reaction to create some turbidity. And that turbidity then is basically proportionate to the amount of cyanuric acid in the water, so that you can tell how much of it is in there.
Now, turbidity for the audience means cloudiness.
Cloudiness, right. Exactly. It's a cyanurate salt, basically, that is created, and that is what's driving the reaction. But, and this is where I think we need to spend a little time talking, there are some interferences to that if you're not aware, you can see some inaccurate readings or some falsely elevated readings because of the differences in water chemistry that may not be taken into consideration. One of the keys there is pH. The reaction is actually driven to completion in a working pH range that is very important. And some of the test kits, the ones that are pretty responsible, will give you a note. And this is just reading right off of one of the ones that I happen to know well. It says for best results on cyanuric acid, pH should be between 7.0 and 8.4, and total alkalinity should be below 240. Mm-hmm. And when you're outside that range, pretty simple, come back and measure the cyanuric acid after you've gotten back into that range.
If the pH impacts this, we know that has to do with hydrogen concentration. So is that saying that you need to be in that pH range or else the hydrogen breaks away or you get more hydrogen on? It's no longer the compound that clouds up the water correctly?
It can mean that. It can also mean that the reaction isn't completing as quickly as you would like to see it complete. And if it's not happening as quickly as you expect it to, you're not seeing that level.
Makes sense to me. Yeah, I know it's always been an approximation. It's very hard to get a really accurate CYA test, and that's from anybody, really.
Absolutely. And so taking it a step further to try to improve the accuracy that's out there, some manufacturers have created a colorimetric version of this melamine test. It's not different in the way that the chemistry works. You're still creating the cyanuric acid salt, or basically a solution of the cyanuric acid and melamine, which is a melamine cyanurate, mm-hmm. and that is then measured colorimetrically. If it's measured with a meter, takes the human eye out of the equation, can get a little bit more precision in what it's seeing, but it's still important to be in the appropriate working range for pH and alkalinity. Those things can still be an interference for that particular chemistry. So while you're getting a little bit more accuracy or precision out of the test, you're not necessarily avoiding the interferences that come along with the method.
Makes sense to me if you think about it, because it's the same reaction. The only difference is I'm either looking at a dot, dropping these things in and using my best judgment, or a computer's doing it for me.
Absolutely. Yep.
All right.
Another important piece of this is a lot of the tests that are vanishing dot tests max out at, say, 90 to 100 parts per million of cyanuric acid. If you hit that range where it looks like at about 90, you see the vanishing dot disappear, you probably want to dilute and do it again, because the limitations on that test, when it's in that 90 to 100 range or above, it looks very similar. And there's, a little bit of, as we talked about already, interference that could be present. And if you think you're at 90 or 100 and you're not, you might be at 200 or 300, but you didn't dilute and see if that's going on. So how do you dilute, right?
That was going to be my question. You're reading my mind. Good for you, Joe.
Half of the water needs to be fresh water that contains no cyanuric acid.
So like drinking water.
Distilled water is your best choice. If you have that available, you can dilute with that. There's no cyanuric acid in it. Bottled water, also great. No cyanuric acid in that. So half distilled water or bottled water, half the pool water that you're testing. Then when you get the result, you multiply by 2.
Makes sense.
So if you got a result of 50, then you're actually at 100. If you got a result of 100, well, you better dilute a little further down and test again. maybe a quarter pool water, right? And 3/4 is going to be your bottled or distilled water, and then you're multiplying by 4.
Mm-hmm.
So if you get a result that says 50 now, you know that you should probably be at a level that's about 200.
I'm just going to put it out there, Joe. If you're having to dilute the sample, you should probably dilute your pool too.
You're over the limit, but you don't know that if you're at the top of that scale and you're not diluting.
Right. And this is what people seem to forget. The higher the CYA goes, it's not linear. It gets more and more severe the higher you go because it slows down your chlorine. And this is widely known. It is so important to know it. And if your levels are so high that you need to dilute, there's a really good chance that is one of the leading causes of whatever issue it is you're facing.
Yeah, absolutely. And in my experience, and I've seen it a lot, our customer base, particularly consumers and even some service pros, don't dilute their test. They don't dilute when they get to 100. They just take, the test kit's word for it. That's the top end of that's what I'm getting. It's 100. Mm-hmm. It might be 2 or 3 times more than that, and you're doing your pool a disservice, fighting those problems in a way that is unproductive because you don't realize what is actually causing them is the cyanuric acid in the first place.
Right. Okay, so colorimetric and turbidimetric, these are fun names. Are there any other ways to test for CYA?
That's pretty much the extent of it. There is, a test strip-based product. It's, again, based on a similar chemistry. So it uses a combination of melamine and some other chemistry that goes along with it to give you a color reaction. Nice thing about that is it does go a little bit higher than your typical turbidimetric test. So in the case of the one that I'm holding, it goes up to 300 parts per million.
Wow.
And it's a great first check to say, is it in the range where I can get a more precise reading using the visual dot test or a colorimeter? And I know some of the colorimeters actually go up a little higher now as well. So that range has been expanded. Just know if your cyanuric acid reads considerably different from week to week, you probably are seeing that interference, right? You're seeing something wrong there. It should be fairly consistent if you're not adding cyanuric acid to the water, because you're not losing much of it to splash out, right?
Right.
So that's one of the things to keep in mind. When you see a difference in the readings and it's something that's unexpected, you're not seeing it, you're not used to seeing it, again, which is why I like tracking it on a more regular than a once a month basis. If you're using a stabilized chlorine product that has cyanuric acid in it. So keep that in mind.
That's a good point because CYA, just like calcium, does not evaporate.
Exactly. And we would get this phone call all the time, Eric. This is one that kind of drove me nuts. But people would like to test their tap water and see if there was cyanuric acid in it. And by and large, there's not, at least not a measurable amount. If it is, it's very small. But the water that we drink is not buffered appropriately for the cyanuric acid test.
Okay.
It's not like pool water. And therefore, when you're doing a test on the tap water, a lot of times you'll get a false positive showing that there's something like 30 or 50 parts per million of cyanuric acid in there when there's not. So again, this is something where once you get your pool filled and stabilized to the appropriate level with that tap water, that's when you go back and test the cyanuric acid because it'll show a more representative amount of the swimming pool.
Interesting. I want to pivot here. Another question we get a lot of is how can you get more precise in reading low levels of CYA, like less than 50 or even less than 30?
Yeah, that's a good question. And it's difficult because the vanishing dot test has its limitations. And it's hard to see that difference of, say, 5 to 10 or 10 to 20, or even the difference between like a 10 and a 30. And the test strip product, one of the limitations on that is the first color block is the ideal color block, 30 to 50. Well, is it 30 or is it 50 or is it 25 or even 15? So it's difficult to get down there. Now, the colorimeters that we talked about before do a better job of getting down to that low level of precision. Right. It doesn't necessarily mean that it's more accurate, but it is giving you a better, to the pinpoint reading. Is it 10 or 15 or 20? But even then I would say, and this is my personal opinion, plus or minus 10 parts per million, you're doing pretty well if you're getting to that kind of precision level. So if it's a 20, it could be a 30, it could be a 10, but you're within, the ballpark of what the expectations are for the test kit manufacturers.
If you know the volume of water and you know exactly how much CYA you add to it, then you know what the numbers should be. and you can look
Right.
at your test and test it. So I was able to do this on my pool because when we refilled it, I knew the new volume, and I added a very specific amount of CYA prescribed by the Orenda calculator and then tested it like, I don't know, a week later, something like that. And it was exactly where it was supposed to be on the test. So I know that that worked, but there are a lot of people that just have no baseline. They don't know even the volume of the pool, or they don't know how much CYA has been added because trichlor, dichlor have been used in the past, or maybe it's a pool pro who's just taking on the pool and it was serviced by somebody else or the homeowner. There are so many unknowns. And I think it's probably a bigger concern to know how to measure it precisely at lower levels than high, because if it's too high, dilute it down. That's a pretty easy process. I think most of us can understand that. When you start getting low, you might need a secondary test to reinforce what you've just found. Is that a fair statement, you think?
Yeah, that's a pretty good idea. I like using multiple methods to see what it looks like down there. Again, you get a little more precision out of the digital instruments that are out there these days. If you have questions about the test result that you're getting, like you knew what to expect, right? You knew that it was in the range of this. And when you got that exact measurement, you knew that that was what you expected.
Mm-hmm.
A lot of times you go to a swimming pool and you don't know what to expect.
Right.
So you don't know if you're getting that appropriate cyanuric acid reading or if it's going to be way high or low. And so when you run into that situation, that's where a backup method, if something doesn't look right, is a great idea.
Yeah.
So maybe you do one method with the vanishing dot and you do it colorimetrically to back that up, or test strip and a test kit, just having a couple methods to compare and see if one of them is, reading differently than the other. Then you got to figure out what that is.
Yeah.
What's causing it.
And it's so important to understand what your CYA level is, but perhaps it's more important to not consistently increase it. Get it to the level you want and stop. And that's the best practice, because CYA will eventually get oxidized out. It just takes several months and you need a lot of chlorine to do it. And then it gets oxidized into uric acid, which sounds very similar to urea because it is a compound of nitrogen. It's also organic too, because there's a carbon, there's a nitrogen in cyanuric acid. And so you're going to get some combined chlorine as you work through it. And we get questions all the time do you have a method for reducing CYA? And there are some products out there that try to do it and varying results at best. But what I'm encouraged by is people are trying. That is great news that people are trying to get CYA out. Of course, we know that reverse osmosis does it. We know that draining and diluting does it, assuming your tap water doesn't have any. But man, it's one of those topics because CYA is so fundamental to both water quality and water balance. I hope that this gets more advanced in the future because it just seems like we're doing our best, but we just can't seem to get super precise on it. So what do you think the future for testing CYA looks like?
I think that there's probably going to be a further development of the method that's there. I know where I worked previously, it was always something that was on the radar, that it would be great to have a test that you could use at a lower range that was more accurate at that low level. And there are lab methods that allow you to get to a lower level, but they're just not practical for swimming poolside measurements.
Right.
I think that further refinement of those lab methods to where they can be used in, say, a colorimeter or, some sort of a monitor of some sort, I think that's where it's headed. But you brought up one other point that I wanted to make here, Eric, and you were talking about the chloramines and the other things, and those are another potential interferent for the cyanuric acid test. So anything that can complex with the melamine salt can also cause an interference for the type of turbidity test that most people in our industry do. And as a result, you can see some false positives when there are high levels of chloramines or, other ammonia type products. So if you get a high result, you're not sure why you're seeing a spike in those cyanuric acid levels, take a look at your combined chlorine level because it might be there. And again, getting back to the whole point of this podcast, if you're something outside the normal expected operating range, whether that be with pH and alkalinity or chlorine or chloramines, and your cyanuric acid test doesn't look right, bring the levels back into the normal operating ranges and then test it again, because you might be surprised that you've been seeing an interference there or combination of interferences. That's definitely something that you'd keep in mind.
I'm going to put you on the spot because this is a brainwave I'm having right now. As you know, Joe, I don't have many of these. Should people consider using some sodium thiosulfate before doing a CYA test? I know thiosulfate is in the drop kit. If you were to put a drop or two of that, neutralize out the chlorine, and then do the test, do you think that could give us some more precision?
I don't know. That's a good question, Eric. I would have to get back to you on that. It's possible that could work. I would say even if you did that and you tested it that way, once you get your balance levels back where they should be, test it again to make sure that you got that right. But
theoretically,
that could work.
Maybe you just shake the sample and force aeration for a minute or two before you go, because you're supposed to shake the sample anyway. Maybe you shake the sample and let it sit for a couple minutes and then test it. But it has to be practical, right? Because pool pros can't keep waiting 3, 4, or 5 minutes for something unless they have something else to do, because they've got to get to the next pool. But homeowners have more time typically.
Sure.
I don't know. Just thinking out loud.
Agitating, though, getting back to your shaking, I don't think you do want to do that, because that, agitation of the water and kind of increasing the aeration in it could also cause some additional turbidity and falsely elevate the test for you. So that might be something that you avoid.
Well, the instructions say you have to shake it for 30 seconds.
Depends on the test.
Okay.
Depends on the test. Yeah. Some of them you're adding after you shake the sample with the cyanuric acid, you're adding that then to get the visual turbidic drop test. So,
okay. Yeah. Well, is there anything else that you'd like to add? This is good information for the audience. Thank you.
The whole point of it is you want to get a good cyanuric acid test. And if something doesn't look right, test it again. Look in the range. Whatever test kit you're doing, there's probably information on the limitations. If you don't have it, it's probably somewhere out there on Google. But probably just know the limitations of the test kit that you're using. That's one of the biggest things that we would see. People didn't read the instructions all the way through to see that there were limitations. So didn't know that the pH should be in this range, the alkalinity should be in this range, et cetera.
Right on. Well, Joe, it's always a pleasure having you on. I appreciate it. We should do this more often.
Yeah, for sure, Eric. It's my pleasure to be on the show with an all-star like yourself.
Definitely not. But this is episode 157. Kind of hard to believe we've gotten this far. And people are still listening to it, amazingly.
All 3 of them.
Yeah. Cool. We're going for 300. Don't sell it short.
Okay.
But at least we know that Jared is not one of them. So
for sure,
we have that going for us. Anyways, thank you all for listening. As always, we try to continue to add value. And if you have ideas for the show, shoot them my way. The email is podcast@orendatech.com. I do have a few more ideas from customers, and I hope to get them out as well. One note, I did have some more experts booked for the summer. One of them kind of fell through, so I'm trying to find a replacement. But we're trying to come up with content that's worth listening to. And we appreciate you very much. So get out there, rule your pool. And for the pros, rule your pools. We love you. Take care.
Thank you for listening to Rule Your Pool, a podcast by Orenda Technologies. For more information on what we discussed in this week's episode, check the links in the description or visit www.orendatech.com.
I hope you find this show valuable enough that you tap that subscribe button and share it with your friends. You can also like us on Facebook and social media. And with our help, you'll be able to rule your pool without over-treating it with chemicals and wasting money. I'll see you next episode.